Alright, so welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we try to see how to build Scikit-Learn pipelines and then some simple EDA pipelines. So what is a pipeline? So the normal data science workflow is that you have some data somewhere, right? Then you ingest the data, then you do some simple data preparation, you manipulate the data, you do data cleaning, then you build some features from it, then you do model training, as everybody knows. Then after building your model, you try and optimize the model, you evaluate your model, you interpret your model, then you deploy them, right? So that is a simple data science workflow for most activities when you're trying to productionize a model. That is a basic workflow. So the best way is to do them in the format of a pipeline or in the format of a framework. So a pipeline is just trying to chain all these individual functions, right, in a particular format that is easy for you to reproduce anytime. So that is the basic understanding behind a pipeline. Just like an assembly line in which every task can be chained together, that it can be reproducible in a very simple way. So let's see another example. So the simple workflow is that you have a session or part of your workflow in which you prepare data, another session in which you train your model, you package your model, you validate, you deploy, then you monitor your model. That is a normal workflow. That is a simple pipeline. But let's see how to use Scikit-Learn to be able to pick some of the components and then create them in the format of a pipeline, and see how to also do something like EDA pipeline. So let's see an example. So the advantage of using a ML pipeline or any data science pipeline is to enable you to make your work very easy and more efficient, right? Just like CI/CD or in DevOps. So let's see how to build a simple ML pipeline with Scikit-Learn and then a simple EDA pipeline. So for working with Scikit-Learn, there are two main things when you're trying to work with pipelines in Scikit-Learn. You need a transformer and then you need your estimator, right? So a transformer is any function. This is a simple picture to help you understand it all. A transformer is any function, right, that takes in data, right, and then it fits and transforms that data into a different format of data that you can use, mostly into data that are containing most of the important features, right? So it is in a stage of data to data stage of a pipeline. So we have two stages. You have data to data and then data to model. So most of the time, transformers are going to pick a data as input, then it's going to return another format of data, right, as output. So examples of transformers are standard scalar, min-max scalar, all of these scalars, as well as all the various vectorizers. They are all transformers because they ingest data, they take in data, then they transform the data, they convert the data, they fit the data, and then produce a different format of data. Then we also have an estimator. An estimator is a function that takes data as input, right? Then it's going to fit the data and produce a model that you can use that model to do some predictions. So an example of an estimator is KNN, logistic regression. So all the ML algorithms are estimators, right? So that is converting data into a model that you can use to make some predictions or do some analysis. That is the basic workflow for Scikit-Learn, right? And that is a simple workflow for most ML pipelines. So you have the transformers stage that convert data to data. You have the estimator stage that convert data to a model. So let's see how to do that in Scikit-Learn. So this is simple description about it, and then we'll work on it simply. So let's import our packages. So we'll be using this particular data set from UCI machine learning, which is about the HCV dataset in which you're trying to predict whether a patient is having hepatitis C or not, right? There are a lot of data sets you want to use, but I want us to use this particular dataset. So you can go to this particular URL and then click on this. Then you can just download the dataset here, right? Perfect. So that's the dataset you are using, and then it's going to give us the various attributes which we have. These are all the attribute information, all of these things, and you're trying to predict the classification, whether the person is having hepatitis or not, right? So let's see how to work with this. So I'm going to load my data sets here. So let me make it bigger so they can see. So I'm going to load the data set. We first of all load our EDA packages that we'll be using. So we'll be using Pandas as PD, and then we'll be also importing NumPy as NP, right? So these are the two main ones we'll be working with. Then also for the ML aspect, we're going to load our ML packages. It's going to be from sklearn.linear model. So we'll be using some models we'll be using as we saw in the picture above. So these are estimators we are trying to import, right? So we'll be trying to see how to work with logistic regression estimator and then KNN estimator, as well as some of the transformers. So I'll come back again here. then I'll load them. So from Scikit-Learn, import logistic regression. Then I'm also going to import the other forms of estimators. So these are all the estimators to be using. So I'll copy and paste them to save us time. Logistic regression. Then the next one is going to be from Scikit-Learn.neighbors. I'm going to import the rest, right? So let me import some of the transformers. So Scikit-Learn. We have several forms of transformers. So we imported some of them. Right. So we are importing these particular estimators. These are our estimators. This is going to be used to do our transformation, and then this is also going to be using. These are the normal utilities we'll be using, right? So from here, I'm going to import my pipeline. So from Scikit-Learn.pipeline, we're going to import two functions. We are going to import the pipelines functions and also have the make pipeline function. We're trying to see the difference between the two of them. So let's start writing some code. So I'll come back again and I'm going to explore our data set that we have. So it's going to be df. It's going to be our data set. We're going to load our data set to df pd.read_csv. Inside my data folder, I have a folder called data. Then I have my data set that I downloaded from here, right? This particular data set. So I'm going to open it. So ACV data set. Then I can now read it out. So head. So if I check it out, we see that we have our data set perfectly well. But as you can see, we have a category column that is a string, and then these, some of them are strings, others are floats, right? So let's check out the shape of our data set. So df.shape. We have this particular data point, 615 data point. Let's check for the columns. So how many columns do we have? Columns. And we see that we have this number of columns, right? But we don't need the unnamed, we don't need this one, so we take it off. And then you have to rearrange the columns well so that this category becomes the target, right? That is standard way of working with supervised machine learning. Now, let's see some stuff you can do. So let's check for the data types. Data types, it's going to be df.dtypes to check for how our data set looks like, right? So if I check it out, most of them are floats, but these ones, the gender, sex, and then the category are objects. So we are supposed to convert them to the right format, right? Then let's see some other stuff from our data set. So check for missing values. If I check for missing values, df.isNull.sum, let's check for how many missing values we have. So we have a lot of missing values in the ALP, right? Alkaline phosphate, and also have some missing values here, cholesterol, and the rest, right? So let's see how to clean them. So this is a simple overview of our data set. Now what we'll be doing is that we'll be trying to do some simple data cleaning, right? As we saw in our pipeline, one of the part of the pipeline is to prepare your data, to clean your data. So how do we do that? So we can easily use Pandas to help us with that, as we are using already, or we can also build a pipeline to help us clean it. So let's check it out with the EDA pipeline for the first one. So this is going to be using a simple EDA pipeline. Right. So there are several ways we can work with EDA pipelines. You can use Pandas Pipe. You can also use another package called PdPipe. You can also use Scikit-Learn to help you with that. So Scikit-Learn have the compose sub package, and then also have the other package that you can also use to the transformers, right? Package to help you do some simple EDA analysis to be able to chain them together. So let's see how to work with Pandas to do some simple pipeline. So we'll work with the first approach of using it manually. Going to do the manual step first, then you will move on to the pipeline approach. So this is how the workflow is going to be. If I'm speaking fast, apologies. So workflow going to be our manual, then we're going to work on the pipeline, right? So let's see how to work with it. This is a simple EDA pipeline. So I'll come back again to my data set that we have. We had a category option here. If I check this one, we had it as this particular one. This is not the best option, right? We need to encode them together with the gender, the sex. So I can just check for the unique values there. If I check out, we have 0 as this, right? So the simplest way is that you can just do something like this. So df can convert this one into a dictionary, and then you can map them out, right? So that's just going to be something like this. This is a long procedure, but let's try it out. So I can call it as my cat dictionary. Create a dictionary from this. I'll manually encode it. So I've created a simple dictionary. So this is a simple dictionary that we can use upon our work, right, to encode the entire stuff, right? So any place that we find this particular category, I want you to assign 0 to it. If you find suspect, assign 0 to it, and then the rest. So we can use this one to map the entire stuff, right? So that is the first method. So the first method, so df dot, I'm going to pass in our category. Then I can just go with map, right? And I'll pass in my cat dictionary, right? So if I do this like that, it's now going to map the entire stuff for us. So this is the first method, right? Using map and using a particular dictionary. You can do it like this. You can also use another approach, which is going to be the long procedure. It's going to be method 2. This is a long procedure, right? It's a long procedure, but not that long. Let's check it out. So I can just go back with this option, because if I go back and I check this one out, we see that how the data set is like, we already have the number there already. All we need is we need to take off this, right? Because we need to take off this particular one. So we can just, instead of mapping, we can just split them off. So dot split, dot string, dot split. We are splitting off the equal to. So now we have only the numbers here. Then some of them also are X. As you can see from here, there was an S behind it. So we also have to split off the S, right? Take it off. So we can just come back again and go with this option, dot string dot get the first index 0. So we only have the zeros, but if I check this one out, if I go back and I do dot unique, you can see that if I do this one, we have the S here. We don't need this one. We need to take off that particular one, right? So how do we take it off? So we can just strip it off by going with this option, string again, dot replace. Going to place any place we find S with empty, right? Something like this, so that we don't have anything there, right? Perfect. Now it is no more there. And now I can convert them into integers. So as type, let's go to int. So this is another method, right? So this is a long method, but it's simple, right? We are chaining them together. So this is chaining the different functions together, but you can also use pipe to help you do this same activity. So let's see how to work with that with pipe. So with using this is a third method, using Pandas pipe, right? So it's very simple. So the format for this pipe is that you have your data frame, right? Then your pipe, then you're going to pass in a function that takes a column and transform that particular column. That is a basic syntax. So you can just do it like this option. It must always return a data frame, right? That is the simplest way for you to work with it. So let's see how to do this particular option. So we can apply this entire function that we did here, this long function, to work on the EDA pipeline, right? So let's see an example. It's going to be this. Let's create a simple function. I'm going to call the function as, let's say we want to map our data, right? So what we want to do, we want to let's first of all, what we are doing, that we are trying to split the numbers from the test, right? That's the activity you are trying to do. So I'll pass in my data frame, right? I'll call it as data frame X. Then what I'm going to do is that I want to pick that particular column that is called category, right? So we can actually specify the column here also. So let's call this my column that I want to pick, right? Column name, and I'll pass in that particular column here, column name, right? Perfect. That is the first one. I'm going to say that for that particular column, I want you to apply all these functions we did. This may look long, but it can be very helpful sometimes. I want you to pick that particular column, and then I want you to apply the same function that we did, this entire big function, right? This function on it. So let's apply this function without the assigning of the int, right? You can even do the same thing, right? Perfect. So we're applying this entire function on it. Then we are going to return the dfx, right? The data frame. So this is a simple function that we can do. So we can use apply map on it. We can use apply to do that. You can use map, but let's use the pipe option to help us with that. So how do you use the pipe, right? How do you use the pipe? So it's very simple. So my data frame that I have, and one thing about the pipe is that this one actually transforms the data. It changes the data frame itself, right? So the best option is to make a copy. So I'm going to create a copy of it. So I'll call it as my df2, right? Then df.copy. Perfect. And then we'll start working on it. So let's see how to do that. So I have my df2, which is still the same data set that we have, the same data set here, as you can see. And then I can now apply my function on it. So df2.pipe, now passing the function, so split from this function that we had. We defined a split number from test. That is the function we are trying to work on. So we're going to split number from test function, right? That is the simplest one. Then it's going to take another column. So this is going to be the column I want to take. I want to take the category column. So category column, right? So run it like that. Now it's going to apply that particular function on it, and voila, you can see that it was very fast. It was able to transform the entire stuff, right? So the column has been changed perfectly, right? Now if I go back and I check it again, so df2.head, it has affected the data. Perfect. So that is the advantage of using this pipe. So it's automatically transform it. You don't need to assign it again, right? It automatically transform it. Perfect. That is how to use a pipe, right? So what you do with the pipe option is that you just create your function, and the function will take in a data frame, and then maybe a column. You can omit this one. Then you're going to do your manipulation of it, right, on that particular function and return the data frame. That is one of the ways. Then you're going to apply it here. Right, you're going to apply it on it. Perfect. Now the other thing we also have to do is that we also want to transform the gender, right? So let's see how to transform the gender, and then let's see also how to transform the gender. So in case I want to transform the gender, I can easily use the same thing option. So let's create that function. So this is going to be a function to map the gender, right? So I can call it as my gender map. So def, or let's create a dictionary. So map gender, right? Which is going to take my data frame, right? You can also, in this case, I'm not going to bring the column. I can also bring the column, but if I leave it without a column, it's still going to work. I'm going to say that take the data frame and then pick the sys column, this particular column, right? Then when you pick that column, I want to do some things to it. So what do I want you to do? I want you to map it with a particular dictionary. So let's go just my gender. So gender dictionary, which is going to take the option of the M, right, for male, also F for female first, which is 0, and then M for male. M is going to be for male, right? I hope you can hear me. Perfect. Then I'm going to apply that particular function on. So df bracket x, right? I'm passing in my column. Then from here I can just say that map this particular gender. It may look long, but it can help you sometimes, right? Then from here I can just return the dfx. So let's return this particular one, dfx, right? Perfect. So that's a simple function. So you are taking the data frame, and you are picking the gender column, this sex column. They are trying to map it, right, perfectly well. So let's see how to work with it. So I come back again, and now I can just go back to the same thing we did. So df.head, right? We have gotten it again, and I can actually map them. So I can pipe them. So df2.pipe. I'm passing my map gender, right? That's going to pick that particular column and do our transformation for us. Very cool. So you see how to use this particular pipeline to help us with that, right? This is a simple EDA pipeline. You can chain all of the pipeline together by using the particular option. So we created a copy. This is the initial data that we have. This is the initial data that we have, right? So I'm going to create another copy. So let's go to copy 3, or let's go to as new data, right? Then I'm going to put this one here, dot copy, right? So I want to do some stuff on it. I want to do the chaining of the pipes. So we're going to chain multiple functions, right, via pipe. So it's very simple. So I'm going to pick my new data that I have, which, as you can see, is having, this one is not transformed, this has not been cleaned, right? So I want to apply that function to it, to both of them at the same time. So it's going to be my this. So my new data dot pipe. Now passing my first function, which was the split numbers from this particular test, right? Now passing my column, which was the category column, right? Then I'm going to do the same thing. So dot pipe again, and I want you to do the gender mapping. So map gender, which was this particular function we defined above, this map gender function. So map gender, So I'm applying two functions to it. The first function is going to pick the category column and do some simple data cleaning on it. The second function is going to pick the gender column, the sex column, and then fix them, right? That is a basic workflow. If I run it like that, and see that it's very fast, right? That's transformed them very fast. That is the advantage of it. This is quite faster than the old process. So if I go back and I check the data set again, now everything has been changed perfectly. So I can actually use this one. Perfect. So that is how to work with a simple EDA pipeline using Pandas Pipe. There's also another package called this. The alternative. This is another method. So this is using PdPipe, right? Which is also another alternative you can also use, right? In which you define different pipes, then you use them. You'll be trying that one later in the future. So let's see how to work with Scikit-Learn transformer, right? So that's another option we can also do. So this is going to be using ML pipeline. This is going to be for the ML pipeline. Pipeline for ML pipelines, right? So I've seen how to work with the EDA pipeline using Pandas, right? There's also another package you can also use, which will be going into details later on, which is a PdPipe. So in case you have not heard of it, this is a very nice package you can also use. So we'll be checking that one later to save us time. And then this is using Scikit-Learn to help us with another machine learning pipeline. So let's see how to work with it. So as we said earlier on, for the Scikit-Learn, we always have a data to data, right? And you also have the data to model, right, pipeline. So the data to data is whereby you're using the transformer, what is also called the transformer stage. Then the model data to model is whereby we are using the estimators or the ML algorithm. So that is a basic workflow for using the Scikit-Learn pipeline, right? So let's see how to do that. So I'll come back again to our data that we have. So we have gotten our data here. If I check it out, our data is perfectly well, but we need to take off this and we need to be able to scale them. So our data is perfect. But if I check out the missing values, we are going to still have some missing values there. So let's go back and equate this one to new data, right? Yeah, just equating it to new data to save us time, because typing new data is going to take a lot of time. And if I go back and I check it out, it's the same thing, but I want to take off this. I want to take off this particular column and rearrange it well. So let's arrange it well. So I can just come back again to the columns session, right? And I want to rearrange it. I want to take this one here. This is simple for me. Okay. So in case you have any question or contribution, you can just put inside the comment section below. And this is going to be the last one. So we must always put, for supervised learning, the recommended way is that put the label or the category or the target at the last one, right? This makes it easy for other people to understand where it is. Then df. So this is something very simple. If I check it out now, it is in a better format. Perfect. So let's remove missing values because there are still missing values there. If I go back and I go with df.isNull.sum, we still have some missing values. So you have to fill all the missing values there, about 30 missing values here. So I can just go back again and go with this option. So in case you want to get the full number, right, this is the simplest way. Just go back again to sum. It's still going to give you 31, right? That is another way of getting all the number, total number of NAs, right? Okay, so let's see how to fill this. So df.fill now, just fill it with 0. In place is equal to true. Right? Now our data set is clean. Yeah, it's going to downcast it, but we still give it like that. So df dot, let's check it again. If there are missing values, no, there are no missing values. 0, right? Perfect. So there's no missing values in our data set now. Now let's see how to transform it data to data, then convert from data to model, right? As we saw inside this particular picture here. So let me show you the picture. This is a lot of things you can learn later on, right? This particular one. So what we are trying to do is that we are now trying to use a transformer to convert the data into an augmented data or a feature. That is the data to data, then you move on to data to model. So let's see how you use Scikit-Learn to help us with that. So I'll come back again, and looking at our data set that we have, if I check this data set here, right, by looking at it straight away, you may be thinking that it's okay. Do we need to scale it? That is the question you should ask. Should we normalize it or should we scale it? Because the age is different, the sex is just 110, the category is not part, but are we supposed to scale the features? Are you supposed to normalize them, right? So how do you know that? How do you know which to do? So this is a simple question. So how to, if to scale, right? Scaling means that you're trying to put them in a particular range. So either from 0 to 1, right? And then a standard deviation of a particular value of 1, right? That is a basic understanding behind it. Then you also have, this is for scaling. It's for scaling, and then this is for normalization, right? So normalization. So normalization simply means that you are trying to use either mean, mass, scalar. This is just offhead. And then scaling, right? Scaling here means they are trying to convert them to that and mostly use standard scalar, right? So min mass is for normalization. It's a format of scaling, but mostly when you are using min mass, you are trying to normalize the data. And then in case you are using min mass standard scalar, you are trying to scale it, right? That is feature scaling. So we want to know whether we are supposed to do feature scaling. So how to know if you are to do feature scaling or not. In most of the cases, recommended, especially if they are totally different, right? So this is 1, this is 7, 18. But looking at this, it looks okay for me. They are almost within the range of 1 and then 100. So it can be, we can keep it like that, right? But let's see how to do that particular stuff. So I come back here, and I can just do a simple plot of it. So let's load our database packages to help us see some stuff. So be importing matplotlib.pyplot as plt, then we'll be also importing seaborn as SNS. So matplotlib.pyplot as plt. Hope there's no mistake here. And let's also import warnings to hide warnings. So I'll be importing warnings. Import. Then from warnings dot filter warnings, right? Then I'm just going to ignore them. So this is to help us hide this particular stuff, right? This kind of errors that you see, right? Which we don't want, right? So that is the basic understanding behind this particular one. Okay, so let's check it out. So let's first of all check the value count. So df my category that we have, then I can just do some simple value count on it. So if I check out the value count for my category, we have these particular categories. So this one is too much, right? That is like an imbalanced data set. We can actually add all of them together and add all of these ones together as one, and then this one as on its own. But let's plot this one out. You can actually plot this one out in two methods. So this is going to be method 1. This is via pandas plus matplotlib, right? Matplotlib. So we can do that one by just going with this option, then dot plot. Then you specify the particular type of plot you want, which is a bar chart. If I go with this option, it's going to give me this bar chart, right, of our values. But sometimes you want it to be beautiful, to give it colors. You can easily use seaborn. So method 2 using seaborn, which is going to be my sns.count plot, right? Then I'll pass in my data frame, and then the new version has been changed, but this is still going to work. So this is also another way which is going to give it a very nice color, right? So which is quite nice. Now let's do the same thing for the gender, right? So I can also do the same thing for the gender to see the proportion of males and females within our data sets. And in most diseases, most of the time, if it is surgical, mostly it is men. If it is not surgical and it's not that risky, it is less risky and it's not surgical, it's mostly female. But if it is surgical and it's risky, it is mostly males that have. So this is hepatitis so it is risky, so it's going to be more males most of the time. So let's go with sex. Let's check it out, and from this you can see that men is 1, right, and then there are more males, as I was saying. So most surgical diseases and risky diseases, there is high percentage for men, and then for non-surgical diseases and medical diseases that are less risky, mostly is females. Let's try the same thing for the DF SNSW count plot for the gender. So I'll check it again, and if I check it out, we see that we have it perfectly well, right? So more males than females, as you can see. So let's see some stuff that we can also do here. We can now move on and then try and see how to apply our transformer and then our estimator. So let's transform this data set and see the score and then leave it without the score. So I'll come back again here, and I can work on the long procedure. Right, so the long procedure is that I'm just going to use my scalar. So I'm going to call it as my main mass scalar. This time we are not normalizing it. Let's not normalize it, because if we normalize it, we cannot normalize this data set. We normalizing it is not the best because they are almost the same range. If I do a simple plot of it, let's do a simple plot of it. So at this plot, if I check this simple plot, you can see that this one is like a bell curve here, right, for the age, and then some of them are the streams. Like this is understandable because it's just 2 variables, male and female. This is also like a bell shape, like goes up like that. This also like that. So in this particular case, the best option is to not use main mass scale, but rather to standardize it. Right, that is the best approach, right? Because this a bell shape, right? This is a bell shape, like a bell, goes up and down. This is not part because it's just 2 variables. This is also not. This is in this particular format. This is in this particular format. So the best option is to standardize them, right? To scale them, right? To use standard scalar, not main mass normalization. So we'll try and see. So in the moment I use normalization, which is a different feature scaling approach, the accuracy is going to be very low, right? So the narrative from this is that we are supposed to standardize them, or we call it as a scale. Right, the reason is that it is mostly in the format of a normal bell curve, right, something like that. So if it's mostly normal bell curve, the best approach is to use standard scaling, right? You can also use normal scaling, that is the normal scaling, normalization, right, which is main mass scalar, but this is going to give you, this can affect the accuracy. Right, so this one can affect the accuracy. Let's check and see how to work on doing standard scaling for this particular stuff. So I'll come back again to what you're going to do. So I'll call it as my standard scalar. And I'll use a standard scalar that we had. Initialize it without giving it any parameter. Then I'm going to scale my data. So before we scale it, let's pick our features and then our labels, right? So it's going to be our features and our labels. So the feature is going to be my S features, as we always do. I'm going to pick the column, everything. I'll drop out the category column. It's going to be as this is go to 1, right? Then I'm going to pick for the Y label, so Y labels, which is going to be my DF, the category column. Right, so this is how to do something. So I've dropped everything out. So if I check the features now, so now we have the features only from age to prothrombin, right? The category is out, right? And the Y label is only the category. Perfect. So let's scale that particular one. So you can scale the entire stuff here, right? So let's scale the entire stuff. As you can see the value, if I scale it, it's going to be like this. My standard scalar dot as I said, this is part of transformation, right? You are taking in data, then you are picking that same data and you are transforming that data into another format of data, right? So we are transforming it, right, from data to data. So I'll come back again. I'll call it as my S-Skilled. I'll call that S-Skilled, or let's call that S-Features Skilled, right? I'll pass in my transform, can just go with fit, transform. Then I'll pass in my features, so S-Features. So now it's going to scale the entire data, right? And as you see, if you can see from here, if I check it back again, you're going to see that this is now going to be in a different format. So features, scaled. But check it out, it's very different, right? It has converted them to these particular numbers. But how do you know the row? So I can just convert the entire stuff into a data frame again. So let's convert it to a data frame. So this is in a list of arrays, but I can convert the entire stuff to a data frame. So I can go to my S features scaled, right? DF. It is too long, but you still keep it like that. And then from here, I can just go with my pd.dataframe. I'll pass in my scaled, this particular one that I've scaled, into my data frame. Now I'll give it a columns, which I'll be using the S features dot columns, right, to give the column names. So if I check it out, my S features now, dot head, you can see that now it is totally changed, right? Perfect. And you can see that now it is between -1, right, and then 0, right, for all of them, right? So this is a scaled data, right? We are using standard scalar to scale the entire stuff, right? So we are using standard scalar to scale the entire stuff. Now let's split the entire stuff that we have, right? And then we're going to work on it. So let's do our train test split. So it's going to be my S train, my Y train. So we are doing S train, S train, S test, Y train, Y test. Then I'm going to pass in my feature. So what I can do that I can actually pass in this particular features. I'm going to pass in this feature here, right? And then my labels. So Y labels. We do not scale the labels because we don't need to do that. I'll give my test size. So let's make it as 0.3. That is 7030. Then I'm going to set a random state of any value. So let's make 42. Okay, so what I'll do is that this is the scaled one, so I'm going to add scaled to it so that we know that this is a scaled data set. SC, right, for scaled. Then we know this one is scaled, right? Now, perfect. So let's do a simple prediction. So to make a simple prediction, this is going to be our prediction. This is going to be our model builder rather. So we have taken some data, right? We took data, we transformed them, we passed the standard scalar transformer function on it. We transformed the data into a different format of data, which is totally different from the one that we had initially, right? This is different from these ones, right? So that is the work of the transformer. Now let's see the work of the estimator. So the estimator is going to pick the data that we said, right, and then transform them into a model that we can use to make some prediction, right? So I can come back again to the same thing that we have here, and then let's work on this. So this is going to be my model building. So I'm going to be using logistic regression. So let's go to LR, my logistic regression model, right, without any parameter. I'm going to fit it. I'll pass in my S train and then my Y train. So S train scaled and my Y train scaled. So Y train scaled, right? So if let's call it scaled. So we run it like that. Now it's going to run it perfectly for us. And if I want to check for the score, I can just check for the accuracy using this particular option. Let's check the score for this, right? So LR scaled model, right? So yeah, let's make it like this. so that it's explicit, so that you know what you are doing. Allow scaled model dot score. You are checking it on the S test and then the Y test. Remember that these ones are the scale data, so I have to put the scale there. I hope I am not so fast. So if I run it now, so the score is going to be, let's check it out again. Let's check what we did wrong. Okay, this was Y test, so we have to fix it. Killed. Let's fix this one. Run it again. Let's check it out. So that is 0.91, right? So that is the accuracy of our model, right? Very simple. So that is using a manual approach, but we can actually use a pipeline to help us with this long approach of calling an estimator, right? And then fitting it on our data set and checking the score, as well as using the standard scaler. I see that it took us a longer time, but we can use a pipeline to make our work easier and to make our work simple. So let's try the entire stuff we have done without the scale data. So I'll copy this stuff here. Without the scale data, we're going to see what we are going to do. This is without the scale data. We're not going to scale the data. We're just going to go straight away with this. So we'll be using the features that we had, the S features, which was this option. Right, this was not scaled. As you can see, it has not been scaled. So trying to see when to use standard scaler, when to use normalization, and when not to even use any of them at all, right? So this one looks okay to me based on the graph we saw, but when we scaled, we got 0.913 using the standard scaler. But when we leave it like that, let's see what you're going to do when we leave the entire stuff without scaling. Let's see the accuracy of it. You can also use a decision tree. You can also use different models as you wish, but let's use a simple one. I'm going to change this entire stuff here. Right, so this is going to be the unscaled one. I'll pass in my data frame that I've not scaled. Remember that the labels are not scaled, so we keep it like that. Right, and let's apply the same model there. So I'll apply this same thing here. And we're going to see the difference between the first one that we have with the scale data and the one without the scale data. So I go back and I call this one as, let's make it normal without scale. So LR model, that is logistic regression model, and let's pass in our values, right? So I'll pass in my values that I've not scaled them. So let's check it out. And then let's check for the accuracy of this particular model. I'll copy this. There's another way of doing it. This we are using the test, right? To see how accurate it is. So this is going to be my test. And this, we can also use a train to do that. You predict on it and then use a prediction to check it out. That is another approach. So let's score it out. And you see that this is going to be higher, which is 0.92, almost higher than this one, right? This is higher than this one. This is 0.91, that is 91%, and this is 92%, right? So that means that leaving the data is going to give you a higher accuracy. That is if you are looking for accuracy, right? But if you want to check for the other metrics, you can also check it. So this is a long process we have done, but we can simplify this entire process using a pipeline. So let's see how to do that using a pipeline. So as we said, the workflow for a pipeline is that we just pick transformers first, right? We're going to convert the data to data. So D to D, data to data. Then it's going to pass that particular data to the estimator, which is going to be my D2M, right, to the model. Then you can also use that one to work on it. So how do you know if something is a transformer? Transformers are always with only fit, right, and then transform most of the time, right? But estimators are mostly the time they only have one implementation. Not one, let's say they also have something simple, but most of the time for estimators we just only fit. We fit and then we predict, right? We don't transform for estimators. That is something simple. So let's apply the pipeline to it. So using the first method, using the normal pipeline. So you're using the pipeline constructor. So it's like this. You're just going to call my pipeline to pipeline pipe. Let's go pipe LR, then pipeline, right? I'm going to use a pipeline. Then this one is a function that takes in some parameters, right? You're going to take in a list of tuples, right? So the first one is going to be your estimator. It's going to be your transformer. Don't forget transformer. The last one must always be an estimator. So I'm going to pass in my transformer. So let's go as my standard scalar. So standard scalar, right? You can give it any name. Then from here, I'm going to pass in the transformer standard scalar. Right, perfect. You must call it. It's a callable function. Then after this, I'm going to pass in the next value. So the next value is going to be the next thing I want to do, which is going to be another tuple, which is going to be my estimator, right? So it is transformer estimator. So I'm going to call it as my logistic regression model. So let's call it as LR model, and I'll pass in my estimator. So this estimator is going to be my logistic regression model or algorithm. Perfect. So this is how to create a simple pipeline. Right, perfect. So by creating a pipeline, it gives you the option of all that we did. You can just use a pipeline to simplify our work. So I can now fit it on my data set. So how do you use a pipeline? If I go back again and go with pip pipeline, I said pip. The pipeline R, right, dot fit, and now fit on my data set, which is going to be my S-train. Right, now this one I'm fitting it on the normal data set. You are not fitting it on the scaled. You fit it on the scaled data set, right? Right, this one you're doing it on the raw data set, right? The one that you have not done anything on it. Raw prepared data. Because you can use a pipeline to do all the processes. You can use it to do this entire process, or most of the data processing. You can just create a simple pipeline to do all of them at once, right? So you don't put on the scale data, you put it on the data that you want to transform, right? Perfect. And I'm going to pass in my Y train. That is how to create a pipeline. So let's store this particular one into another variable. So pipe LR for logistic regression. But it's going to train it and do everything for us, and it's very fast. It's doing 2 steps at a go. Now from here, I can check out all the various methods of this particular stuff. So these are the methods and attributes of this. So if I go with DIR my pipe LR, right? So you can see that this is going to give me a lot of things, right? So these are all the various things I can do. I can just get the parameters of it. I can get the name steps, right? I can get all of these things, right? I can fit predict, right? I can fit transform. It's inheriting everything from what you have placed there. So let's check the steps within our pipeline. So the pipeline can have a lot of steps, right? It can have a lot of steps. So in case you want to check for the steps, right? Just go with my pipeline for the logistic regression. Now just go with my steps. If I go with steps, it's going to list all the various steps within this particular pipeline for us, right? It's an attribute. So it's going to tell me that the first step is an estimator with this, and the second step. I can also get the entire details of the entire stuff, right? I can also get it as a name. In case you want to get it as a dictionary, right? So you can just do the same thing. So pipe LR, right, dot named steps. If I go with this, it's going to return it as a dictionary. It's supposed to be named. I spelled it wrong. Dot named. It's an attribute. So let's send it as what? As a dictionary that I can actually select one after the other, right? So since this is a dictionary, you can actually pick each and every of the steps using the same option, because this is a dictionary. So come back again and then pick what I'm getting here. So I can pick this standard scalar, right, as a key, because this is a dictionary. You can treat it as a dictionary. To bring it out for us, right? Very simple. So in case you have a lot of steps and you want to know each and every of the steps, you can use this one to check for the steps there, check for the keys of the steps as a dictionary, then you can just pick them out individually. You can also get all the parameters, like the details about this. This is going to be to get the details, right, of everything. It's going to be my pipe LR, right? And I can just specify that I want to get all the details of this particular steps, right? So how do I get all the details? I can just go with my get param. So this is going to give you all the details plus all the parameters. So details and then params that is being used, right? And now it's going to give you a very nice explanation. So the steps, there are 2 steps. We have the first step, which is going to be our transformer. The next step is going to be our estimator. It's going to tell you that for the standard, for this one, these are the parameters, right? And then the rest, right? It's going to give you all the various parameters that is being used. So these are all the parameters for the logistic regression model. In case you also want to pick a particular step, right, to do some simple analysis or to understand that particular step, you can also go back again. This to pick a step, right? If you want to pick a single step, just go with my pipe for the logistic regression model. Then I'll just go with my steps. Then I'll specify that I want to pick one of them. So I want to pick the first one. So it's going to tell me that this is the first step, right? Then in case I want to pick the parameters of this, I want to get the second one, right? It's going to bring only that one out, right? Then I can now just go in and say that I get the parameters of that. It's going to give me all the parameters of that particular one, right? So this is the parameters of a step. So to pick a step and then get params of it. That is a basic workflow. So it can be used to do a lot of things. You can also use the same thing to do reverse transformation of your data, right? In case you want to do inverse transformation of the data. So that is something very simple about it. Now, how do you make predictions? How do you check? So you can actually check for the accuracy of model of your pipeline, right? Like this. So let's go with my pipe for the logistic regression. Now go with my score. I'll pass in the same thing I did above. I'll pass in my S test and then my Y test. It's going to give me the score. So this is higher, right? 0.91, which is like lower than the previous one. So in this same thing I have done here, right, I can actually apply a different estimator, right, to it, and a different transformer. So let's try an example here. So I'll copy the same thing here, and instead of me doing the long process, I want to compare the standard scalar with the normalization, right? So this is going to be for normalization. So let's call this LR, but let's call this one as normalized. So NOR, right? Normalized. This is normalized data. I'm going to change this one from standard scalar to min mass. So let's call this min mass scalar. And I'll use the min mass scalar. Then you're going to see the result. So this is going to be min mass scalar. Perfect. So something very simple, something very basic, using the same model. Then this makes it very easy. So you can just be changing these ones and this one without going through the long procedure, right? Then I can now pass in my pipeline norm. I can now fit it on my data set. So pipe line for the logistic regression model, the normalized data dot fit. I pass in my raw data, S train, the Y train. This has been very long. Apologies for that. I'm going to work on it and let's check the score, right? So I can also do the same thing and check for the accuracy of this. So paste it here to save us time. And let's convert this one to norm. If I check this one, you're going to see that now the accuracy is going to be so low, right? So that explains why sometimes you have to know when to use feature scaling, right? That is standard scalar, and when to use normalization, that is min mass scalar. And you see that when we use min mass scalar, we got a very low accuracy, but the one we left it like that, it was having a higher accuracy, and the one we scaled it with standard scalar, we got 0.91, right? That is something very simple about working with pipelines. So thank you for watching this tutorial. So in another session, we're trying to see how to create our own custom transformers, our own custom estimators to be able to use it in our pipeline. So this is the first method, right? Using the pipeline constructor. Let's check the second method before we go. It's going to be method 2, using the make pipeline. So this make pipeline is a simple format which allows you to be able to make pipeline just like we have done above, but it's very simple. But before we work on it, let's see how to make some predictions with what we have done, right? So I'm going to make predictions because what's the point of getting that crazy if you can't make predictions? So let's make predictions. I'm going to pick some data set from the test, and then we're going to see how to make some prediction on it. So let's go with my S test. Right, then I'm going to pick some of them. So let's pick 0. So this one is going to be, right, there's a value here. We're going to predict and check and see whether we're going to get a prediction. So let's convert one to list. Right, and I'm going to be picking this one. So this is going to be our values. So let's go to my sample, example 1. Right, and if I check for the same thing for the Y test, that's ilog. It's supposed to be small case here. It's 0, right? So we know that it's going to predict us 0. That means that the person is having hepatitis, right? That is what we know for this particular values here. So to be able to make a prediction, you are supposed to transform them. So you have to reshape dataset as a sample. I'm shaping that as a single sample with many features, right? So that's how we are seeing it, because that's how we trained it. So it's going to be like this. So look at my sample 1, right? So np.array, I'm passing my value, my array. I must reshape it. So I must reshape it as 1:1. So we are reshaping it as a single sample with many features. Perfect. Now let's make our prediction. So if I check it out again, this is how it looks like, right? This is better, right? So now I can make my prediction. So let's make our prediction on this. So we can just use any of the pipelines. So let's try it. So I'm going to call this my print. I'm going to call this one as my logistic regression. So LR model scaled, right? And then this is going to be print LR model normalized. Right? I'm going to see which of them is going to give us their prediction and then their different accuracies. Okay, so let's check it out. So I'll open this like this, put it here. I'll go with my pipe.lr, right? To make a prediction, just go with predict. And you pass in our example, so sample 1, right? So this one was for the normal one, and this one was for the norm, right? So I'm using 2 of them. So let's check it out. And voila, all of them give us a good prediction, right? So all of them give us 0, 0, as we saw it here as 0, right? That means that our model is accurate, it's giving us the right prediction. And then we can also check for the prediction probability. What is the percentage? Because there are 4 different classes there. So we want to know the percentage for each and every of them. Probability for each class, right? Probability. So we want to know the prediction probability for each and every of the class. In that case, it's going to be like this. Instead of predict, it's going to be predict proba. So it's going to pick the entire stuff and give us the percentage for each and every one of them, right? So we have the reason it gave us 0 because in 0, that is the first class, we had this particular percentage. This percentage is going to give you a maximum value, right? The one with the highest value is going to give you the result. That is why this one was the first one, 0, 0. That is something very simple with using pipelines. You can actually see the pipeline, which is going to make it very easy for you using JobLib. But now let's move on to using the next method, that is make the pipeline function, which is very simple. So let's go to my new pipeline for the regression. Like I just go the same thing. So make pipe. There's another way you can also do that. There's another method. Then here using this, the difference between this particular one and the other one, that this is going to call the constructor, but you don't need to specify a name, right? So this one, you don't need to specify names. No, you don't need to specify names for the steps, right? You don't need to specify the names. Like here, we, as you saw earlier on, from here that we specify the name for that particular transformer, right? Or for that particular estimator. Using a make pipeline, you don't specify, it's automatically going to generate the name for you. That is the difference, right? No need of naming steps. It's going to automatically generate it for you. So let's see how to do that. So I'm going to pass in my scalar, so standard scalar, right? Then up, which is this particular function. Then next one is going to be my estimator, so logistic regression, and that is all. So that is how to do that. Then you can now fit it on your data, right? So that is the simplest format. So you can now do the same thing. So pipe LR, so new pipe. It's the same thing that we have done. Dot fit on our data set, which is going to be my S train and then my Y train. Remember that this one is not scaled. And now we can also make our prediction, right? So you can check where the score, as we did above, you can do all of these things. So I can just come back again and then run it again. It's still going to give us the same result. So let's try it here. Let's add another one to it. So I can call it as my big pipeline. So make pipeline. So a new pipe. It's also going to give us the same result, right? It's the same thing. There's no change behind it, right? Give us the same result. You can also check for the probability of them, the accuracy of all of these things, and still can give us the same result. That is a basic overview of all that you have done so far. So thank you for watching this long tutorial. In case you have any question or contribution, you can just put it in the comment section below. So the basic idea is that you have understood the concept of working with EDA pipelines using Pandas and then PdPipe, and also how to work with Scikit-Learn pipelines, which is going to work with transformers and estimators. So a transformer will take data, right, and produce data. An estimator is going to take data and then use to produce a model, right? That is the basic difference between them, and they are very useful because you can use to do a lot of things. It makes your work easy for you. You can actually save these estimators, these pipelines, and use it later on for any activity you want to do. So thank you for watching this tutorial, and see you another time. Stay blessed. Bye.